In this lesson, we'll explore the different technical implementations of changes. Now, when considering any change in a technologically advanced environment, it is important to recognize the vast network of systems, applications, and configurations that are interwoven into a delicate balance to create a given enterprise environment. Now, a single alteration, however small it may seem, can actually send dangerous ripples out across this intricate network of interconnected systems, which can then lead to unforeseen consequences. So, in this lesson, we're going to be exploring the technical implications of changes, including some key elements like the use of allow and deny lists, restricted activities, and the complex interplay of applications and their dependencies. First, we have allow and deny lists. Now, allow lists and deny lists are going to be used by routers and firewalls to either allow or deny certain resources from being accessed. An allow list is going to specify which entities are permitted to access a given resource. On the other hand, a deny list or a block list will be able to tell which entities are prevented from accessing a given resource. Now, anytime a change is proposed, it's important to review both the allow list and the deny list to determine if you need to have them modified as well. If you perform a simple action like adding or removing an IP address, for example, this can actually inadvertently grant or restrict access to certain critical services. If you're upgrading a firewall, it's also important to conduct a firewall rules review to ensure that your existing rules will work on your new firewall and that they're properly migrated into the new device as well. If you do not have the proper allow list or block list in place, then your system may not function properly and your security will be compromised. Second, we have restricted activities. Now, some tasks or operations might be listed as restricted due to their potential impact on a system's health or security. Before greenlighting a proposed change, it is required that you verify if the proposed changes could have any restricted activities contained within them. For example, a change might involve accessing a protected database or shutting down a server that is considered too sensitive to reboot or to take offline during regular business operations. By knowing these restrictions ahead of time, you can prevent data breaches and operational hiccups from occurring. Third, we have downtime. Any proposed change, no matter how small, does run the risk of causing downtime to your systems. Therefore, it's important that you take the time to estimate the potential downtime and weigh its negative effects against the potential benefits of the proposed change. Will the downtime cause any issues for your end users during peak business hours? How will it impact your users or customers? It's important that you understand the impacts of any downtime, and that way, the change can be scheduled during a scheduled maintenance window to minimize the negative impacts of the changes related downtime if there is any. Fourth, we have service restarts and application restarts. Now, many of our proposed changes, like installing a critical piece of security software, will require that services or applications are being restarted for that change to be applied. Now, while this might seem pretty straightforward when you're installing a security patch or other piece of software on your home computer, a simple restart like these can especially be disruptive when they're being applied to a domain controller or other server that is actively being used by all of your end users. Remember, it's not just about the time it takes for the service to be restarted and to come back online. It's also about the potential data that might be lost in transit or the backlog that could be created during the associated downtime while you're implementing a given change. So you have to keep this in mind too. Fifth, we have legacy applications that we need to consider. Now, legacy applications are older pieces of software or systems that continue to be used, often because they still function and meet the needs of their users, even though newer technology or updated versions may be available. Now, these legacy applications may still be robust and reliable, but they are particularly sensitive to changes because they are generally less supported than our modern applications. These legacy applications might not be as flexible or adaptable as their modern counterparts, so even a minor update in one part of the system could lead to malfunctions or crashes of these older applications. For these reasons, it's important to understand which legacy applications may be existing inside of your environment and how they might be affected by a given proposed change. Sixth, we have dependencies. Now, in today's interconnected systems, everything is linked together, which creates these dependencies. For example, an application might rely on a specific database to provide the underlying data for a particular service. A change in one area, therefore, might have cascading effects throughout all of your systems, your networks, and even across your partner's architecture too. Before implementing any proposed changes, you should map out any of your dependencies that exist. Otherwise, a minor tweak in one area could lead to a major outage in another area without you even realizing it. So remember, the technical implications of a change are multifaceted and they're interwoven throughout all of our systems and networks. Technical implications of proposed changes are not simply about understanding the change itself, but also involves grasping the change's potential impact on a broader scale across your enterprise network. By taking into account elements like allow and deny lists, the nuances of downtime, and the intricacies of application dependencies, cybersecurity professionals like you can ensure that the changes are not just effective, but they're also efficient at minimizing disruptions and maximizing your potential benefits.